Hey, what's up guys? Welcome to the fourth lesson in the C++ in 2021 series. So today what we're going to do is we're going to create a dummy input manager class that will show off function callbacks and function pointers so that we can register simulated implementation functions for handling input in a hypothetical game engine, let's say. So we're going to do this in a very straightforward way. We won't go into all of the details, but we'll be fairly thorough in our process, at least showing how to using most of the important functions that you'll likely need throughout your journey. And if you need more specific functionality, again, go get the book Professional C++ by Mark Gregoire. There is a link down in the description. And as always, if you like this series, you're learning as much as I am, hit like, subscribe, and all that crap. So let's just get into it. So the first thing we're going to do is we're going to clean up our main function. We're just going to move all this vector stuff into its own function. So void vector stuff, and we will just literally just take all this vector stuff and move it into here. With that done, let's start working on that input manager class. So the end goal, let's block out kind of what we're looking to do. So the end goal would be something like we have a game class defined here, and within our game class we have a function. Let's say a boolean handle mouse event. And we'll just make it take a string for now. And the event itself is going to be a string, and means that we'll import string from up here. We want to be able to register this handle mouse event into some sort of input handler. So we are going to forward declare our input handler. For now, input handler, input manager. So here we're going to have a private input manager. And what we're going to want to do is inside our input manager, we would want to have let's say an init function that registers handle mouse event with input manager. Right? So that's basically what we want to do. We want to register this with our input manager, and when that's done, whenever the input manager detects input, it will call out to any functions that we've registered to it. So let's create our input manager. So let's create a new folder or filter, and we'll call it input. And we'll create a new module in here. We'll call it input manager module input manager. There we go. One thing I did learn in the interim, Christopher Iman, I think it was his name, in the comments on the modules video, he pointed out how we could separate our implementation from our module interface. So we can create a new CPP file. We'll call it inputmanager.cpp. And all we need to do here is put module input manager. Now you see here how it says module is undefined. You can just ignore that, basically. Now inside here we can create our input manager class. So we will do class export class input manager, and then inside our main.cpp we'll import our input manager class, and then we can remove the forward declaration, and all of that should build, I imagine. Yes, and it built. So we've got the basics in place. So our InputManager class, what is this going to do? First, there's going to be some public stuff and some private stuff. So let's just make those labels. In the public section, there's going to be a couple of functions. There is going to be a register callback function. We'll take a type, an event type, and it will take the callback, which event callback. Now we need to define what these are. So the event type is simple enough. It's the type of events we could have. So in an InputManager, you can imagine there's a mouse, keyboard, gamepad. Let's use those three. So let's do enum class event type, mouse, keyboard, gamepad. So we've got that. Now event callback, this is where we start talking about today's subject. So we'll start off with the legacy way of doing it, the non-standard way, which what we're going to do is use function pointers. So we can create a type alias. I think that's how you say that word. A-L-I-A-S, alias. If it's said differently, who cares?
Alias.
Hello, darkness, my old friend.
So with the using keyword, using event callback equal, and then we will define our function. So function pointers historically have been defined as the return type with a star, and then I believe it's like this. And in this case, if we look here, we expected a standard string. So we'll do standard string. And we need to import string. And we will also import IOStream as well. Actually, we don't need IOStream here, but we'll import string here. And what this will do, this is a function pointer, which can hold a function that returns void and takes a string as a parameter, right? So we want to be able to hold a list of these callbacks inside a private variable, and we're gonna hold them in an unordered map of vectors. And that will be defined here. So std unordered map, and it would be event type and vectors of event callback. And we'll call this callbacks. So let's define our register callback function. Let's let IntelliSense try to do that for us, and if it takes too long, we'll do it ourselves. Okay, we'll do it ourselves. Now let's copy this. We'll go into InputManager, paste it in, take that. And here we will this is where we will import IOStream. And this will actually be initialized to its zero initializer, and that should build. Again, you see a bunch of squiggles. That's because IntelliSense is incredibly slow as modules still. Hopefully Microsoft is working on that. At least Microsoft has support for modules. That's something I'll give them. So with register callback, it's going to be fairly simple. What we're going to do is we're going to say callbacks type dot pushback callback. That's all we'll do. So what that's going to do is it's going to take the callback and it's going to put that callback inside the vector of that type. And that should still build. Good. With that done, we can now, we'll need one more function. We'll call it void, let's say detect input, and it will take a type, and it will have the message. And this is just to simulate a input detection. So you can also call this, we'll call this dispatch message. That's what we'll call it. And this will dispatch a message to all of the listeners of that type, or all the callbacks that are listening for that type, right? So let's copy that and implement it down here. And again, we'll put this. And this will be very simple as well. We'll do for auto callback in callbacks of type, and we'll do callback message. And that should work. That should build. And it builds fine. So that's our basic interface. We shouldn't need to touch this too much until we look at newer conventions. So, spoiler warning, this isn't going to work straight out of the box for this use case, because this function, the functions here, they are our object functions, so they're bound to the object itself. So what it will work for right now though is a global function, an unbound function. So if you do void handle mouse event std string message, and then let's import format here, and we'll just do std count std format the message, and let's put a new line in there. Now, in theory, that should still build. Since IntelliSense isn't working properly, I'm building periodically just to make sure I'm not screwing up anywhere, because sometimes I rely too much on squiggles. So, with that being said, we can now create an input manager. So we'll create an input manager. And with that input manager, we will register callback, and this will be input manager event type mouse, and we will pass it the handle mouse event function. So this will register the callback into this unordered map, and then when we call dispatch, it should dispatch the message that we tell it to dispatch through that function, which will print the message and then the message. So with that done, we'll hit dispatch, input manager, event type, mouse, and then we give it the message, and this message is for me. And will that build? No. Dispatch is not a member of input manager. Dispatch message. Okay. Let's actually rename it dispatch. And dispatch. All right, let's build that again. That builds okay. And when we play it, we should see this message is for me. And that's exactly what we were expecting. Now, what if we tried to do this within the function here? What would that give us? And just for demonstration purposes, we're going to return to the actual game struct later. But here in our init function, we do something similar. im.register callback, input manager, event type, mouse, and here we would do something like end handle mouse event, right? And what happens if we try to do that? Here it says illegal operation on bound member function expression, right? So now if we tried to do something like this, IM is an undeclared identifier because this is technically static, so it's not able to resolve itself. It doesn't work in the end. We'll come back to this and I'll show you how to get it to work, because this is what we want to do. But first, let's move away from function pointers. So let's rebuild this, make sure it builds, good. So this is a function pointer. Now this is the old way of doing it, and it has all the limitations that, it has the limitation I showed you and some more limitations that are not really worth going into. What we could do, however, is use the standard library provided type std function, which is in the functional header like this. So instead of void star here, we would do std function, then angle bracket. So the syntax is a little bit different, but it's a return type, open parentheses, and then the parameter types. So in this case, std string, and close that. And with that done, everything should still work. You see here it builds and it runs. So this, in the background, does the same thing as what we were doing with this pointer, except for it's a standard function. That's all well and good, but it still doesn't solve this issue, because like I said, this is still doing basically the same thing, right? There we go. Now, one way we can fix this, one way that it's recommended to fix this, if you want this to work, is instead of passing the pointer to the string directly, what you can do is you can actually pass a bound function into the function itself that accepts the callback. So what we're going to do here is we are going to use the standard function called stdbind. And what stdbind does is it takes first parameter, it will take the function you're trying to bind, so game handle mouse event, the object that you're trying to bind it to, which in this case is this, and then the parameter list that that you want to pass into it. In this case, is one parameter, so what you're going to want is std placeholders _1. So what this will do is, for the first parameter of this function or of this method, it's going to put it in the first slot. So if you did this, what this would do is when this callback is called, so in here, right, where it says callback message, let's imagine that the callback message takes two parameters, right? We call it like this, message and one. Now, if for some reason you want to in the background, so here there's like, let's just say this takes an int, right? Int num, and here. There. So let's just say, for example, you're trying to pass a function in that has this signature, but all your other functions have the signature where it's reversed, where string is first and int is second. But you don't want to, you can't rewrite the function definitions because they're already in use. You can use this bind functionality with these placeholders to swap those to forward them in different directions. So here you'll notice here that the second thing passed in is going into the first slot, and the first one passed in is going into the second slot. So when we go here, the first one, which is string, will go into the second slot as string, and the first one here, or the second one, which is an int, will go into the first slot defined by placeholders 2 in the first slot here. You can do that. And you can also use bind to bind non-member functions as well, but those are to swap the parameter order, but it's not really it's not something you're going to want to use very often. So now with this, we can let's copy this, put this here, and add the message variable here. Now, in theory, that should build. No matching token bound. What am I missing? Oh, I need another one of those. That should build. I'm undeclared identifier. Void init struct. Oh, it's not IAM, it's InputManager. There. All right, and this one here is just demonstration. I should remove it, and it builds. So the bind functionality here forwarded the bound the call to this function into here and stored it into our callbacks list, and then properly calls it back here. This message is for me. And actually, that's not right. We're not calling it yet. So now, so we bound it this way. Now we can remove this. And we can actually just create our game. Create our game, call init on it, which will register the callback. And then we can call, and we will create a function called run, which we'll just call InputManager dot dispatch InputManager event type mouse bound message. We'll call that. And now we can go down here and call g.run, and we should get bound message being printed in the debug window. There were errors. What's the error? Handle mouse event must return value. So this is a Boolean. Let's go here. We defined it as void. Let's change it to Boolean. So if you want to stack your callbacks and only use a certain amount, I'll show you that in a second. And yeah, so let's play that. What's going on? Handle mouse event must return a value. Oh, I still didn't. All right. Is that gonna work now? No. InputManager event type mouse. Oh, and we have this defined at the top from the last lesson. And there we go. Everything's working better now. So remember, putting stupid defines in your code is probably not a good idea overall. But we got it working, and now if we run it, bound message shows up in the window. So this is one way to do it. The other way to do it is using Lambdas. Now Lambdas are useful because you can use Lambdas basically anonymously without doing too much work. So let's say, just as a quick demonstration, we want to just have a function that just says, let's just say, we'll call it is even, right? And we give it two numbers. Let's just say template type name t, and we'll say t num1, t num2, and we give it a callback, right? And we say we give it a callback here. Now with Lambdas, you can just put auto if you expect to always use it in the same way. And this is called I believe it's called a templated Lambda or something like that. And what that will do, it will actually generate, basically works like templates, but with Lambdas. So it will determine how your usage of the function, and then automatically generate those functions accordingly. So here we'll call it Boolean, and let's just say we call return callback num1, num2, right? Now I believe with that we're able to do something like this. So we can call std count, std format is even, take that, and then we do is even, and we let's say one, let's call it is equal to keep it simple, is equal, and then we'll call it is equal 1 2, and then we will give it a lambda. So the way lambdas are declared, and lambdas are anonymous functions, I should have mentioned, is we put square brackets, that's called the capture list, put parentheses, which is the parameters it takes, and we put curly braces, which is the function definition. So with that in there, we can define it. Now we know that this callback is going to call two numbers together, so we are going to call it with let's say int num1, int num2, because we know we're passing integers, and I think we might actually even be able to do this. Let's try this. Now auto is super powerful these days, so that's why I'm showing off with auto. So auto num1, auto num2, and inside here we will do return num1 equal num2, right? And I think that'll work. Let's see. And that worked. So what this will do is it will check if it's even and call this function, which will take two numbers of an arbitrary type and call them on our callback, where it will take two numbers and run equal on it, but doesn't even need to be numbers. Now let's run this. We'll see is even is false. And now if we take 2, is even is true. Now, since everything is defined as auto and it's all lambdas and everything is templated, what if we do this? What if we take two strings? Auto, auto. And is that going to be equal? Yes, it is even. It's equal to each other. Now, if we put another letter in there, is even is false. Now, you're going to see this is the kind of thing that happens actually in a lot of standard function, standard library algorithm functions, which we'll probably go over at some point. And a lot of times this will be done. So this is how it works. Now let's say we want to check if these two numbers are even to like a number here. So let's say number to check against 5, right? Now let's go here. We'll take 1 and 2. Now if we want all the numbers to be equal to 5, we want to have access to number to check against. So let's go here, number to check against. And if we try to build that, it's going to give us an error because it's not captured. Now, I mentioned that these square brackets are called your capture list or capture brackets or whatever you want to call them. It's the capture zone where you capture the things around it to pass into your Lambda. So if you put an equal, you're capturing everything automatically that's within scope by value. And technically, you're only capturing the things that you use. So if you have number to check against in here, it will capture this by value, right? So if we run here, false. Everything is not equal to 5. But if I put this to 2 and I change this to 2, then this should all become true. It is even as false. Well, why is that false? Oh, because Boolean 1 is not equal to 2. So, and num1 equal number to check against, and num2 equal number to check against. There. Now that should work. True. All right. Okay, so if you use equal, it'll pass everything by value. So if we do here, at the end here, we add a plus here, it won't actually even let you do it. When you capture stuff by value, you're not allowed to change the values of the stuff you capture. You can, however, allow yourself to change that number that you captured by value by putting mutable after your parameter list. So if you do this, this will come out false, because what happens is num1 equal num2, and then num1 is equal to 3, right? And then this checks against 3, and it becomes false. Everything's false. Now, but if we print that number to check against again, print number to check against one more time, then you'll see that it is still 2, even though we changed it. Now, if we decided to pass it by reference, which is by doing a default capture with the end symbol, which is the reference symbol, you'll see that it still returns false, but it changes the number to 3. So that's mostly what you need to know about lambdas. There's other things here. You can make this a const extra, and you can give it a return type, but we'll get to return types in a minute. So that's the basics of lambdas. Let's delete this. We don't need this. And let's go back up here. Our std functions here can also accept lambdas, and it makes lambdas make binding stuff easier without having to remember this bind syntax. So we can go here and do InputManager, register callback, and we'll put a second callback inside here. InputManager, event type, mouse, and then we can put a lambda. So we will capture list, parameter list, and function body declaration. Now, the important parts about this. We know we're binding to this function, right? We want access to the stuff in this class, in this object. So we can also bind this in here. And that will give it, that will basically make it like the lambda is running as part of this class. It's the easiest way to explain it. There's probably some nuances where that's not quite the case, but for the most part, that's it. We know that the function signature we're looking for, we need to register, is a std string. And we also know that it needs to return a Boolean. Now, to declare your return types, you're going to declare it in what I believe is called trailing return form, where it's an arrow and bool. And that's all that's needed. Now inside here, we can, what we're going to do is we're simply going to forward this to our handle mouse event and give it, we should probably give this a namer parameter and message here. There we go. Now, if we play that, we should now get 2 bound messages because we're looping through all the bound callbacks. So one last thing that I want to go over is that just quickly in our input manager, I mentioned how why we were returning Boolean, because here you notice here that we're looping through everything. Let's say we want to be able to block if a certain layer has handled the message. So we do if this returns true, then we'll return, right? And if CB returns true, the message has been handled and should not propagate further. And then we can go inside here. So now we'll go back and we'll only see one, right? We only see the one bound message because it hits this one. It goes into the handle mouse event and that returns true. Now if we flip the order of these, Let's move the comment with it. If we flip the order of these, and instead of returning handle mouse event here, we just call it and we return false. It's no longer going to block that layer, and it will keep on going. And see, now we've got 2. That's everything we're going to go over today for our input manager and our function pointers, function std function, and our lambdas. If you're looking for more in-depth information on the subject and a bunch of technical details and a few other things you can do with bind and stuff like that, go buy the book. It's a great book. Otherwise, thanks for watching. Thanks for learning. Always cite your sources and hit like, subscribe, and all that crap. See you next time.